Welcome and thank you for joining us today for this SPE Tech Talk with Jereh. I'm your host for this broadcast, Joe Sinnott. As industry operators focus more closely on environmental, social, and governance, or ESG metrics, natural gas has become a preferred fuel for frac equipment. Changing primary fuel on location to natural gas has led to more efficient, cleaner, and higher horsepower equipment. In turn, embracing these changes has led to impressive technological advancements. We're joined today by Jereh to discuss some of these advances, including both direct-drive turbine-powered frac pumps and electric frac pumps. We'll also look at how this evolving tech could impact the future of frac operations here in the U.S. And if you would like to impact the future of today's tech talk that you've tuned into, then I encourage you to use that comment box to ask questions, provide feedback, and to share your concerns or challenges or whatever else you might have to say about today's topic. Because as is always the case here on these real-time tech talks, our guest will address as many of your questions as possible later on in the show. And if you don't have anything to share just yet, then at least go ahead and let us know where you're watching from, or tag a colleague who might benefit from today's frac-focused conversation. And before we begin that conversation, let's take a look at today's audience poll question, which is, what is the future of frac equipment? Is it A, direct drive turbine, B, e-frac, C, diesel gas blend, or D, something not yet invented? Go ahead and let us know your answer. Provide any extra color that you wish to add on to your answer in that comment section. And we'll take a look at the results later on in the show. And of course, get our guest's reaction to your responses. And speaking of our guest, let's go ahead and introduce you to Lyoid Fussel, Vice President of Business Development with Jereh. Lyoid's experience has spanned all aspects of oil and gas operations, from completions and production through disposal and manufacturing. He has been an integral part of many new technology advancements, most recently focusing on alternatively fueled equipment for high-pressure pumping applications. Lyoid holds a degree in industrial engineering from Kansas State University. Well, hello, Lyoid, and welcome to SPE Tech Talk.
Yeah, thank you. Good morning. Nice to be here.
All right. Well, we are very happy to have you here today, Lyoid. And if you would, can you kick us off by giving us a little background on the transition to natural gas as a primary fuel supply for field solutions?
Yeah. So back around 2012, there was a big push by Halliburton to initiate natural gas as an alternative fuel source. That, they basically focused in and said, this is the alternative fuel source that we've been looking for. And they made a big push and converted a lot of their fleet vehicles and their operating equipment to DGB and their fleet vehicles to compressed natural gas. And they did a lot of press, and they were handing out little Hot Wheels at conferences and things, advertising that they had converted their fleet vehicles to natural gas. And they partnered up with Chesapeake and made a lot of progress back in around 2012. But at the time, the industry quickly discovered that we weren't quite ready for that transition, and there wasn't enough available fuel quality natural gas to deploy to the field. And at the time, they were using a lot of LNG, and there wasn't enough LNG facilities near where the actual work was taking place. And so the transportation and access to the appropriate fuel source, natural gas, became an issue. So that was back in 2012. But their strong push and the results that they had whenever they had access to a fuel source really demonstrated that it was a good solution as an alternative fuel source. It would reduce emissions, and it was less expensive if we could figure out how to get it closer to where we were working. And so that initial push by them really led to a lot of developments in transportation, a lot more facilities where you could access compressed natural gas. And it also led to a lot of developments in field conditioning of field gas, because at the time, field gas wasn't really appropriate as a fuel solution. And we recognized that the easiest way to solve this problem is we have gas all around us. Let's make that gas useful. And so their initial push, while it didn't quite go the way they had planned, it did lead to a lot of advancements in the industry. And it did make people recognize that natural gas could be our solution to a clean burning fuel source.
Great. So I appreciate the timeline, the history. So I guess in summation, they recognized a decade ago that if they could use this fuel, it made a lot of sense for a lot of different reasons.
Right.
Now that we're at that point where having access to the fuel and figuring out, I guess, some of the, the ways in which you can use it and overcome some of those hurdles, those hurdles have largely been overcome, but that leads us to the technology. So how are we using it? Figured out if we could use it, it would be great. Now it's a matter of how we're using it. So can you give us some color on the actual technology using natural gas for both, again, direct drive turbines and EFRAC?
Yeah, sure. So initially, the first use for it was with conversions on diesel burning equipment to DGB. And so they basically made it so you could cut up to like a 65 to 70% cut of your diesel with natural gas, and you were displacing diesel at that point. Well, one of the best engines for burning natural gas is a turbine engine. And so there was a company, one of the initial companies that did that was Greenfield, and they created direct drive turbine equipment that could burn natural gas. There was some, it was an early development, and there were some things that could be improved on that. But the turbines did prove to be very efficient at burning the natural gas and produce a lot of power, a lot more power than you could get from just a standard compression engine. So direct drive turbines became a thing then and started being developed. And we could get, instead of getting a couple of thousand horsepower out of a pump, you could get 3,000 to 5,000 horsepower out of a pump. And that starts to shrink the footprint whenever you're getting more horsepower, more condensed horsepower per unit. And then since the turbines are efficient, we had a turbine on every single pump, and people wanted to figure out a way to disperse and not have to have so many turbines on location. And with the development of electric frac pumps and electric motors, we realized that we could get 5,000 to 7,000 to even maybe unlimited horsepower out of an electric motor. But you needed a very large amount of electricity in order to do that, more so than what you could get just straight out of the grid. And so we started looking at large turbine generators, 30 megawatt generators, generally LM 2500s, and large 30 megawatt generators that would be able to power up to 10 or 12 electric frac pumps. And that's how we kind of got to where we are now, was because the natural gas was able to be burnt more efficiently by the turbines. And so turbines kind of moved in as the new solution to the future of the industry, because you could 100% replace diesel if you were burning natural gas in a turbine, whereas with a combustion engine, you were still, the equipment that had been converted, you could still only displace about 70% of your diesel consumption.
Got it. All right. Well, thanks for that color there. Again, just continuing to build the history to where we're at today. I do want to take a moment to pause and remind our audience, of course, that you're free to ask whatever questions you have. We have our guest. This is a live show, so use that comment box. Ask us your questions, offer your feedback, and of course, any challenges or concerns that you've had perhaps in your company trying to make the switch to these new technologies. Let us know, and we'll have Lyoid here opine on as many of those comments and questions as possible later on in the show. But for now, Lyoid, I guess let me ask you, in lieu of questions from our audience, what are some of those challenges? Some of the, maybe some of the disadvantages of these technologies, and of course, maybe you can expound upon some of the advantages too. So, can you offer some insights on the pros and cons of what you've just described?
Yeah, sure. So, the pros initially for diesel were that it was readily available. We had plenty of supply. We had plenty of transportation network built in, and diesel's it's been proven over decades as being a very reliable fuel source. One of the drawbacks to initially converting to natural gas is that not all the natural gas that's available in the field is fuel quality natural gas. Turbines can burn a wide range of BTU, but they don't like liquids. They don't like liquid hydrocarbons. They also don't like water. So while they can burn a large BTU range, you have to make special effort to ensure that all of your gas stays in the gas phase and you're not putting liquids into the engine. So that's one con, is you have to think about your fuel source a little more. You can't just go fill up a tanker and bring it to location. If you're going to use field gas, you've got to properly condition that field gas. You have to do some analysis and some studies to make sure you understand your BTU range, your condensates, your liquids, and that you properly address all those things. As far as advantages go, though, the natural gas that you have in the field obviously is going to be your least expensive fuel source, since the operators, that's their product. So it's going to be less expensive than purchasing and transporting diesel. Another benefit is that the turbines, because of their high power rating, the amount of energy they're able to produce from that gas, you can greatly reduce your footprint. So a traditional diesel fleet, you're looking at 16 to 25 pumps, depending on what kind of rates you're pumping on location, for a 50 to 60,000 horsepower fleet. For the turbine and electric frac equipment, with electric frac, you're looking at 8 to 10 pumps. With direct drive, you're looking again at 8 to 12 pumps that are replacing 20 to 25 pumps. So you've greatly reduced your footprint. Now, the electric equipment does require you to have a large natural gas generator in order to power it, unless you can connect to the grid, which is possible if you have the grid capacity for that. But if you have to use the large generator, yes, the large generator does have a footprint, but it's still not quite as big as an additional 10 hydraulic frac pumps, and it can be moved away from location. It doesn't have to be on the exact same location as the electric equipment. So that's some of the benefits and negatives that I see with using natural gas as your alternative fuel source for this new direct drive turbine and electric frac equipment.
All right. So taking all of those variables, all of the pros and cons, taking all of your insights that you've amassed throughout your career, I want to ask you, Lyoid, to take a look into your crystal ball right now and share your thoughts. What do you think the future of frac operations, at least here in the U.S., are going to look like?
Well, I do believe that the electric frac equipment is the more popular kind of through publicity and the public opinion, et cetera. The electric frac equipment, whenever it's on location, if you're able to connect to the grid, for example, there's very little noise that's created. It's a very quiet, very environmentally friendly operation in regards to disturbing the community. And there is a extremely high horsepower rating that you can get out of the electric equipment. In addition to that, the electric equipment has you can fine tune your injection rates. You can fine tune your pressures. They have a lot of controllability because there's no gears. There's no lockouts that are required. I mean, basically you can set exactly down to the decimal point, exactly how much rate and pressure you want to produce with the pump. So I think the electric frac pumps are definitely going to be one of the leading technologies into the future. And I think that whenever we have people that focus in on the grid required to operate them, and we're able to run them off of the grid instead of localized generators, I think that's going to be a big benefit. And that's one of the things a lot of people are looking at is trying to make, basically microgrids or subgrids, where instead of putting your generator right on location, you could basically stack some generators off location and transfer that power through power lines and build like a temporary grid where you could run the equipment. To me personally, I think at this time, that's kind of what the future is looking like. I think that's the direction most people are trying to move.
All right. Well, we've all heard Lyoid's predictions for the future now. You just said that, you're assuming that most people might be on board, but let's go ahead and revisit the poll question that we asked earlier. It's also in the chat. So for our audience here, we asked you at the beginning of the show, what do you think the future of frac equipment is? Direct drive turbine, A, or B, E-frac, C, diesel gas blend, or D, something not yet invented. So again, to our audience, let's hear your thoughts. What do you think the answer is? Do you agree? Do you disagree with Lyoid? And if you care to share some color, I'm sure Lyoid would be happy to offer further insights about that. But for now, we do have one question, and I think it builds on what you were just talking about, Lyoid. So you're saying, maybe in the future, being able to use grid power and different ways to electrify frac operations, if you will. And we have a question that's come in that says, what do you think about using turbines, electric pumps offshore? Would a frac boat with LNG tanks be viable? Thank you for
I
that
mean, we
question,
have.
Michael. And yeah, Lloyd, what do you think there?
Yeah, thank you for the question. We have been definitely focused. The industry's been focused on finding better ways to transport natural gas and LNG. And with the development of large tankers that transport the fuel for export purposes, daily we come up with new solutions for transporting and storing LNG and CNG. I don't see I don't see an issue with using the turbines as in electric pumps offshore. One possible concern is sometimes the turbines they're sensitive to their orientation, be it their vertical orientation, and so that could be a potential issue with using them in an offshore boat. However, if you accept that they're a good solution and you wanted to implement them, that's what we're here for, is to find ways to overcome those issues. So I do know that turbines are used in offshore applications because the U.S. Navy and other navies around the world use them as power in their submarines and boats. So it's definitely a proven technology that works on the water. And as long as you had a viable fuel source that you could move with the turbines, they could definitely be used in offshore applications. And they can easily be skid mounted. The direct drive turbines that we personally build are trailer mounted in the US, but internationally they're skid mounted. And it's easy to put the skids on a boat. And if you have a fuel supply, they can absolutely be used on offshore frac boats.
Great. So you threw a lot of the different, options that are out there, Lloyd. And again, this continues to evolve, but, is there a primary consideration that operators or companies have in mind when they're deciding between electric fleet, direct drive turbine, DGB fleet? What, there's one thing that jumps out to you in these conversations.
Yeah, it's easy. I mean, they're all good solutions, and there are applications where one is better than the other. So if you're just moving into using natural gas as your fuel source, DGB is the easiest to implement because it's the most familiar. It's the same compression engines that you've used in the past. You're just displacing some of your diesel with natural gas. So DGB is absolutely a viable alternative, and it does improve your emissions and your environmental footprint for sure. And it's one of the easiest to implement. You can put in a conversion kit on your standard diesel equipment, and pretty soon you're burning 60 to 70% natural gas. In regards to direct drive turbines, one of the benefits of the direct drive turbines is the footprint, because in a direct drive turbine scenario, what that means is that every hydraulic fracturing pump has a turbine associated with it. So you have a lot of smaller turbines on location. So if you have 10 hydraulic pumps, in our scenario, you have 10 turbines, 10 smaller turbines. And so you don't need a big generator separately. Each one is kind of independently powered by its own motor, its own engine. And so if you're in a very remote location where you have a very small footprint, say you're in sort of a mountainous or an area where you're unable to make a large footprint pad, those are definitely, you can get a lot of horsepower in a small space because those units are smaller and they're individually powered. Now, if you're in a wide open space that has a strong grid, there's no doubt that electric frac would be the best possible solution in that scenario, just because of how, if you remove the generator from location and you're running off the grid, the amount of power that you can get from the electric frac is really unmatched, and the cost savings if you're connected directly into the grid would be unmatched also whenever you're not burning the fuel locally. But so each one has a unique application solution where it fits the best. And DGB is certainly one of the ones that people go to first because it is the easiest to implement, and you can convert some of your old equipment into DGB equipment. But if you're looking to move into the turbine market or the e-frac market, you're going to have to upgrade your pumps, because 2,500 horsepower to 3,000 horsepower pump is not going to be enough to get the full utilization of a direct drive turbine or an electric scenario.
Got it. So plenty of obviously fuel considerations, space considerations. once you've made that decision, what about maintenance costs? How is it maintaining, these new types of equipment versus, what people would have seen in the past with more traditional diesel pumps? Can you talk a little bit about those considerations to the extent they are a consideration?
Sure. Yeah. I mean, the interesting thing is, normally whenever you have a new development and you have your cost benefits analysis, for every benefit you get, there's a negative that you get. And that's really kind of not the case with this new equipment. Traditional diesel equipment, everybody knows the maintenance that's required there with your oil changes, your oil filters. There's lots of fuel injection systems that need to be maintained and things like that. With the turbines, they're really actually pretty low maintenance. I mean, as long as you provide them with good clean fuel, there's not oil changes that have to be done. There's not filter changes that have to be done to the extent that you have with a traditional diesel engine. And in regard to the electric pumps, the maintenance basically moves over to the turbine generator. So if you're able to use a grid scenario, which the grid scenario is ideal, but in the U.S., our grid isn't quite to the point that it needs to be in order to operate electric frac equipment. So you are going to have the generator initially, until we upgrade our grid or our infrastructure to where we can handle it. But if you don't have a generator on location, the electric frac equipment maintenance is almost non-existent. I mean, you still have to do maintenance on your fluid end and your pump and your valves and seats, but the actual power system for the pump, electric motors, they have thousands of hours before they need any sort of service whatsoever, and there's not liquids to change and filters to change. So believe it or not, the maintenance actually goes down significantly on direct drive turbine and on electric frac compared to a traditional diesel fleet or a DGB dual gas blend fleet.
Got it. And I mean, one thing you shared in there too is just the waste stream, right? You're talking about, not having the filters and the waste and the stuff that ultimately goes into a landfill, right?
Sure.
So I guess kind of flowing from that answer that you just gave and thinking about the headline for this conversation, right? An ESG focus and how it ties in to some of the decisions. How much do companies factor in, or maybe I should say, how do they factor in things like a reduced waste stream and some of these things that might not be as easy to quantify as fuel savings and smaller footprints and stuff like that? How do those conversations go when, again, people are trying to figure out how they want to proceed?
Yeah, I mean, I think that that's a thing that is frequently overlooked as the waste stream that's involved in the maintenance, for sure. But yeah, I mean, operators across the board are really starting to focus in and trying to use ESG as their focus because, well, it's being pushed by the public and by some regulatory things that are coming through. But also, it's proven over the last decade that if we focus in on that, it is achievable. So when we first started talking about, trying to reduce emissions and, trying to protect the environment and stuff, the tendency is for us to not want to make, as an industry, is to not want to make a lot of changes because what we're doing works and we're familiar with it. But what we've definitely seen since the service companies and the manufacturers have agreed with the operators that let's focus in on ESG and let's make less emissions and let's burn cleaner fuels. It's really developed into this incredible increase in horsepower and reduction of footprint. It reduces the amount of people you need on location. It reduces the amount of truck moves that have to be done on the highway. I mean, the ramifications expand well beyond just the fuel that we're burning and our emissions, because we're no longer having the emissions from 20 diesel trucks to move the frac equipment to location. We only have 10 now to move the 10 pumps. So it really spreads out a lot. And it is something that we, point out to operators that are just starting to expand into the alternatively fueled equipment field. It's something that we definitely point out to them and help them understand. But, the main point that I kind of wanted to make today that I haven't really focused in on completely is that when we embrace the changes that are coming and we recognize, electric vehicles is something that's getting a lot of discussion right now. And there's people that are for EVs and people that are against EVs. And, we in the industry, we understand the complications of EVs. They're not a perfect solution to the world's problems, because for every resource that's clean in an EV, there is a resource that's not so clean that creates that. But what I can say is that we should embrace that, because EVs do not mean that the oil and gas business is going away. Electric vehicles require the oil and gas business. And while the public may not realize that in general, we as an industry need to recognize that. We need petroleum to build the plastic that makes the parts of the car. We need the petroleum coke that's created in order to make the anode material for the batteries. I mean, electric vehicles don't exist without oil and gas. But what would happen if we were powering vehicles with oil and gas or with electricity is we can start building more and more natural gas power plants. And natural gas is something that we have an extensive amount of in the US. We have a very viable supply of natural gas for the future. And so let's power more vehicles with natural gas, which is essentially what you're doing when you're talking about electric vehicles. So everybody gets caught up in the politics, and there's the left and the right and the argument about it. I say embrace electric vehicles if that's a viable temporary solution or a permanent solution. We can absolutely charge electric vehicles with natural gas. It doesn't have to be coal, and we don't have to worry about, oh, well, there's all these problems with making the electric vehicles. That's just another example of what's coming forward. Look at the amount of power we get from an electric frac pump and compare that to what you could do with electric vehicles, and think about it and say, you know what, rather than fighting it, let's figure out how to help it. Let's help move that technology forward, and let's be the leaders. That's my opinion.
Oh, I think it's an opinion. I think it's rooted in facts as well, which helps when you have opinions rooted in facts. That being said, I think I have one final question to kind of wrap up everything you just said. And that is, maybe putting on your skeptic's hat, if you will. I've spent plenty of time in the field. I can, go back 12 years or so ago when diesel pumps would start up, you'd see the plume of black smoke, right? And to see now how far we've come, especially here in Appalachia where I sit, that, the embrace of what you've just been describing clearly has a positive benefit, both from an environmental standpoint, from a social standpoint, certainly from, from an economic standpoint, an efficiency standpoint. This all sounds good. But yes, the reality is humans by nature, especially in our industry, can be skeptical, right, Lloyd? Mm-hmm. So, maybe as a parting comment here, I'd love you to address that one lone skeptic who just listened to you for the last 30 minutes and still isn't totally convinced that this new technology and everything you just described is all that. I'd like you to make one final closing argument, if you would, okay, Lloyd.
Yeah, okay. So I can see where the skeptics are like, well, this all sounds good. Why hasn't everybody converted? Well, it costs money. It's not cheap. You have to make an investment to do the conversion. But if you look around at the companies in the industry that have started to make the change, ask how many have changed back. That's what I would say to the skeptics. So the guys that started out with diesel and they converted to DGB, how many of those are uninstalling their DGB kits to go back to diesel? I'm pretty sure that I'm hypothesizing, and I'm fairly certain it's correct, that it's zero. And if you ask yourself how many companies have added electric frac to their fleet and they've sold off their electric frac and only kept their diesel, the answer is none. The guys that have implemented both end up selling off their diesel equipment and keeping the electric. And the same is going to be true for the direct drive turbines. There's a few companies out there that are doing the direct drive turbines, and you'll notice that they don't, whenever they make a change up of their structure, that's what they keep, and they get rid of the diesel. So that's what I would say to the skeptics. I guess the proof is in the pudding, because it's a learning curve. There's definitely things that you have to understand to move into the business. But if you just look out at the industry and see what's happening, you can see there's more and more of this equipment rolling out, and there's less and less people that are interested in the old diesel equipment. And I think that basically the proof is in the pudding. And so for the skeptics, that's what I would recommend, is to look at the people that have done it and see how many are retreating. Everybody that's made the change and made the investment, they're moving forward, and they're going to be coming up with even more technological advances, so that at some point we're going to be behind again with what we're doing currently. So that's the one thing that's always for certain. Everything changes.
All right. Well, with that, Lloyd, I appreciate that answer. If there are still some remaining skeptics out there, what's the best way for them to get a hold of you, to find more information, to make their own decisions
Oh,
here.
I'd be happy to discuss the topic with people anytime. And my email address is lyoid.fussel@jereh.com. It's on the screen there. Feel free to email me. I'm on LinkedIn. I'm not hard to find. I actually have my own podcast that we recently started called Oil and Gas Lighting. So people can tune in there and call in to me and my co-host, and we'll answer your questions there as well. I love talking about the industry. I love the new technologies that are rolling out. I think really great things are happening, and I'm happy to discuss it with anyone. I'll also be at HFTC in a couple of weeks there for the HFTC conference. So swing by the Jereh booth, and I'll be happy to answer your questions in person. Look forward to meeting you.
All right, everyone. Well, I think it's very clear that if you want more information, you have no excuse. It sounds like there's plenty of ways.
Plenty of ways to get me.
Everything short of showing up at your doorstep, Lloyd. I think
that's even. You can even do that.
Too.
Just knock on the door first.
All right. Well, that being said, Lloyd, thank you very much for sharing your insights on how a focus on ESG is compatible with and leads to technological advancements that can, again, enhance the bottom lines of companies and certainly enhance the ESG, the environmental, social governance profile of our industry. So
yes, I think if you're leading, then you set the course, and that's what we should do.
All right. Well, I agree 100%. Hopefully our audience agrees as well. With that, Lloyd, let me say thank you one more time to you.
Thank you, Joe.
Offer a special thanks, of course, to Jereh. For those of you watching, if you want to watch a replay of this conversation today, go ahead and head on over to the SPE Energy Stream, the industry's digital pulse. Visit streaming.spe.org. I'm your host, Joe Sinnott. Join us again next time right here on SPE Tech Talk.
Thank you.
The energy industry is evolving rapidly. To stay informed, you need relevant content available when and where it's convenient for you. Introducing the SPE Energy Stream, the energy sector's platform for quality content from around the world. Energy Stream gives you access to technical solutions, innovations, trending topics, thought leadership, market outlooks, and education. From original programs to exclusive SPE event presentations, this easy-to-navigate platform features insightful content delivered live and on demand. Explore insights from industry thought leaders, then save the videos that interest you so you can watch them at your convenience. Stay ahead of the curve. Start watching SPE Energy Stream today.